Yeah, if you got one of those. Hi there. Okay, let's do this session. I'm Rob Tiffany. We're going to, hopefully you're in the right place if you're into mobile devices and SQL Compact. And actually, you know, I'm getting more and more agnostic around SQL Compact. All my friends on that team say, Rob, quit talking about this database like it only belongs on Windows Mobile. When we came out with version 3.1 and now we're at 3.5, it runs just about anywhere. It can run on a desktop, a laptop, a tablet. It even runs on the server. We don't really recommend it, but it runs there too. So the big gist of this talk, though, if you've been into any of my sessions at other conferences or read my blog or whatever, you might see me spending an inordinate amount of time trying to see how far I can push SQL Server with replication. It's one thing to get a white paper and see how to connect the dots and get it working. I've seen in the years past, you go to MSDN and download a white paper and it shows you how to set up SQL Server and get replication working on an XP machine all with everything together. And you feel like, wow, I made it. And then you go try to deploy it at your company and you wonder why you're having trouble scaling or performance or things like that. So I've spent a lot of time over the years, not just because out of weird curiosity, well, it's a little bit of that, but I've actually had customers where I've had to do performance, benchmarking for them to prove to them that we were ready for prime time. We have all kinds of competitors in this space that you may or may not know about, and so to me, it's important that we show up to the party, that we say, yeah, we can scale, we can do this. And so what this talk is about is going beyond just showing you how many concurrent users and how big a databases you can sync with one SQL Server. I've already done that session a lot. I talked about it in this book here, where I give you all the steps. This is kind of a beginner book to walk you through. A lot of customers are intimidated by merge replication because there's a lot of steps and a lot of security settings and a lot of tiers. And so this book is about just kind of holding your hand and walking you through that, and then giving you some tips, around hardware and networking and storage to improve that. This talk here and the book I'm working on now is to go beyond that, because at some point you're going to saturate SQL Server. You can use all the tips I give you and all the tricks with hardware and everything else and software tuning, but at some point you're going to saturate SQL Server. It can only take so much. Now hopefully that'll be tens of thousands of devices when we're talking about one SQL Server. But then there may be, when you go to the next level of company size, for the very largest companies, or a company that needs to break apart the way it replicates, then there's another method called Merge Replication Republishing, which is kind of interesting. There's almost no documentation on it. It's kind of like a black art. And so I took it upon myself to take that away from that world and try to make it more concrete. And so I'm working on a book that talks about how to do that. So I want to show you, and what this talk is about, and I'm going to show you, I've got 4 servers running on my laptop in virtual machines, and I'm going to show you how you can scale out SQL Server in a more hierarchical kind of pyramid where you can support more devices, hopefully hundreds of thousands or millions. I don't want to stick my neck out too far on that one, but that's the gist of it, is break it apart. So the takeaways as I walk you through here, we'll show you about just normal SQL Server publishing, which you may already know about if you've done this before. Then I'll show you a little something different where you have another SQL Server who is a subscriber to the big SQL Server at the top of the pyramid, and then how it can then publish its subscription down to another node below it. And then we'll talk about the IIS, how it works with replication, and then lastly, the code on the devices. So I'm going to show you 4 tiers in this situation. In my book and other things, I'll talk about even more tiers than that, about breaking SQL Server into a separate publisher and distributor to get even more scalability. So hopefully the takeaway is when you get through here, you'll have a good, confident feeling that this is something you could actually implement. If you have that particular scenario where either you need to scale to hundreds of thousands of users, or you have a scenario where it needs to be segmented in a way that you're doing differently today. So here's the dream, right? SQL Server at the top, serving the whole planet. I'm replicating down to SQL Server subscribers that are in cities all around the world. And then those subscribers are republishing their data back down to devices in those different regions. I'm all about debunking the myth that we can only go so far with replication. There's nothing you can't do with merge replication as far as how far you can push it. It's just knowing how to do it, and that's the big problem. Is a lot of people just don't understand to do it. So this is kind of the dream, but this next slide might be your reality. And so it doesn't have to be about scaling to the whole planet. It might be just a scenario like this, where this is kind of a typical, company manufacturing at the top, distribution center, warehouses in different locations, serving and delivery drivers, and they're serving customers in different cities. Your company may serve. And so today, and in the past, when I talk about replication, we talk about there's filters that you can do in SQL Server to limit the data to particular, for instance, drivers. I'm a driver that supports this particular city or this village or this neighborhood, and maybe my driver ID is 25. And I filter data, and it only gives me information about the customers that I care about and the orders that I care about, and not everybody else's. So that's normal merge replication. But if you need to support another layer in the middle where you want to filter twice, then republishing would be helpful for you in this department. So if you visualize at the top, let's say an order gets placed for a product up at the top, and there's the SQL Server publisher, and so the person takes the order and inserts that data into the big SQL Server at the top of the pyramid. And then beneath it here, we'll have two different distribution centers where you see the forklift drivers. And one may be here in Barcelona, one may be in London. And they are going to filter data. There's a function in SQL Server called hostname. They may pass the name. They may pass, when they replicate, they may pass the name Barcelona. And they're only going to pull data back that's relevant for orders and customers that live in Barcelona. And so they'll have that subscription. And the same for London or any other city. Then you have delivery drivers that belong to a certain distribution center. But they don't want to see all the data for Barcelona, for instance, either. They have different routes that they drive. So they just want to see things that belong to their route. So you take the subscription at the distribution center at Barcelona and you republish it. You run the publication wizard against your subscription, and then you make it available down to the drivers. And now the drivers, they use their host name filter, and maybe they send up route number 2 or a name, something they can filter on, so that for this distribution they only see customers and orders that are appropriate to them, and then they can take care of their customers. So this is just kind of a way that you can imagine in your mind how you could break apart SQL Server through successive levels of filtering so that you get less and less data as you go down the chain to the people at the end to help take care of your customers. So let's dive into this. So we'll start out at the top of the pyramid. So I've always talked about publishers. Now I'm talking about the global publisher, or a much bigger publisher than normal. And well, let me ask you a question. I don't want to assume too much. How many people in here have actually worked with merge replication before? Okay, so just a few of you. Okay, so I won't try to go over people's heads then. I apologize. Publication in SQL Server. Let's say you've got an enterprise database that you use to run your company's business and has all the information that you use. So merge replication allows you to run these wizards to make that database available to devices or to other SQL servers. And so rather than doing a lot of programming, you can use these wizards. And so I can say, yes, here's my inventory order database, or whatever you want to call it, and I want to publish it out. And so I'm going to run through some wizards, and I can make the whole database available to everyone, or I could just choose certain tables, and within those tables I can choose just certain columns, and I can do all kinds of filtering. I can filter. If I have a database that has lots of tables with 10 million rows per table, it probably doesn't make sense to push 10 million rows down to SQL Compact on your device or laptop. So I can do filtering that filters everybody, and then I can also do unique filtering like I described before, where I just say, send data that's only appropriate for Barcelona. So we'll run this publication wizard to make this happen. And then we have these table filters. And the filters is a whole art form in itself, but it gives you a lot of power to do things. Now, I notice here I talk about a trade-off between using GUIDs or using identity columns for your primary key on your tables. Very common for people in SQL Server and other databases to use it some kind of auto-incrementing, integer as their key, and that's very common. And so SQL Server has this built-in ability to distribute different sets of keys. You can imagine the scenario if I synchronize a bunch of data, 1 through 10, and everyone else gets the same data, and then I decide to insert a new row, a new order on my device, for instance, and it increments to 11, and someone else does 11, and then we try to synchronize, we're going to have a primary key collision, and so the data is not going to go in. That's a problem. So SQL Server handles that for you by doing something called identity ranges, so that people won't have the same ID. So now you replicate everything down, and then on a user-by-user basis, it might say, well, this user number 1 here, she gets identity columns, identity numbers 1 through 1,000. And then this user over here gets 2,000 through 3,000, or just things like that. And it blocks them up into groups, and you can set them out. And then when you've used about 80% of those, your SQL Compact database, when you replicate, will notify SQL Server and get another block of unique identity columns that won't clash with other people. So that's how SQL Server handles it. And so it's pretty straightforward when you're doing just classic replication. When you're doing republishing, it adds a complexity, because now you have multiple layers. You have SQL Server subscribing and getting blocks, and then they have to assign blocks to devices beneath them. So it makes it a little trickier. And because of that, some people have said, it's an American expression, I'm just going to punt on this one. I'm just not even going to try to make this work. I'm going to use GUIDs that I know are unique everywhere on the Earth. And so I won't, maybe not on Mars, but on Earth, these are going to be unique. And so I'll use GUIDs for my primary keys, and I don't even have to think about it. And SQL Server doesn't have to have the overhead of worrying about all those kind of things. And for you, that may be a good option, and I'm seeing more and more people do that. If you're using other sync technologies, like Sybase's Mobilizing synchronization server for their databases, you need to go that way. You need to do, if you're using our new sync services for ADO.NET, you probably need to use GUIDs for keys as well, because it doesn't support the advanced functionality that Merge has. So there's a pro and a con there. As any DBA would know, integers, and then maybe 32-bit and maybe even 64-bit integers are going to perform better on joins than a data type like a GUID, which is 16 bytes wide. Making that your primary key and indexing a GUID is not ever going to be as efficient as a 32 or 64-bit integer. So those are the trade-offs. You need to do your own testing, but at some point, if you build the largest system and it's really complex, you may want to tolerate a slight performance hit on multi-table joins with GUIDs versus having to deal with the crazy array of identity columns. But it's all doable each way. The last thing I have on here is I talk about these regional subscribers. So we're still not talking about devices just yet, but we're talking about other real SQL servers that are subscribing. And so those of you who have done replication with devices know that it goes through IIS, and it translates from a binary, and it goes to a proprietary protocol that goes over the web that's compressible. But those of you who have been using replication for server-to-server replication, which we've had since the 1990s with SQL Server 7, we've had that for a long time. We have a binary, high-speed, very fast, very efficient protocol for synchronizing servers together that's much faster than the same thing when it has to go through IIS, because there's not that extra layer in translating. So regional subscriber SQL servers, they're using the fast binary, and they're getting data that's just appropriate to them. Then the reason I say here on this last bullet, I talk about severing the connection to your global publisher, maybe during working hours. And you may not even have the option to do that. The only reason I say that, it has to do with the way you lay out your database. And to try to simplify it, if I'm getting Barcelona data and I am somehow able to make a change in the data I get that all of a sudden it'll go back to the Barcelona database, then goes up to the master database. But if it's something that affects other side, it could go up and back down and affect and kind of potentially defeat some of the purpose that I'm trying to get, the gains I'm trying to get by republishing. If a customer moves from Barcelona to London or to Paris, then they're kind of breaking through the partitions. And I'm not saying that can't happen, but it takes away from some of the benefits I'm getting. So one thing you can do is if you can sever the connection to the top SQL Server during the daytime, then all these devices are replicating all day with their SQL servers, and they're only having to worry about the workload there, and they're not also having to worry about keeping this one up to date. And then when you reestablish the connection, maybe when the workday's over, then these SQL servers will help this top one catch up. Anyway, but a lot of options there. So another place I spend a lot of time in helping optimize replication for customers is around the hardware and helping make sure they have the right hardware to do the job so that they can scale to these extreme levels. And so when we're so right now all I'm talking about is just really large systems. And if I can get it to work for a large system, you can probably get it to work for your small system. But for extreme cases, if I was going to do replication for a giant, like for a Tesco or a Walmart or some other giant company like that has branches, stores and things everywhere, then I need to make sure that my SQL Server publisher has all of the horsepower it needs to do the job. And it doesn't mean just a SQL Server and everything sitting on one disk and IIS all sitting there with it. It means a lot of things that if the DBAs in the audience here know about in tuning SQL Server or tuning any database, Oracle or DB2 for that matter. And so I kind of talk about, up here you see kind of the disk arrays, RAID 10 just about everywhere on your arrays, and then hopefully if you're able to, separating, so I'm going to install Windows Server, on this drive, and then the SQL Server is on the next drive, and then the database that I'm making available to everyone, that's on another drive. Its log is on yet another one. There's some replication system tables that most people never see or don't know anything about. They do a lot of work, and it helps to get them onto their own drives. The tempDB database, that's an art form in itself, pre-sizing the tempDB for performance, and its transaction log. So whether those are separate drives, separate spindles on your SAN, separate LUNs, whatever you can do. And I know it's not possible sometimes to get what you want. I know a lot of people come in and they talk to the storage people. Maybe you're using EMC SANs or some other technology or Hitachi, and you might get pushback saying, I'm not going to give you all that. Try to get that, and then if you can't, get an SLA, a service level agreement from your storage people guaranteeing a level of I/O, performance if in fact these different areas are going to be sharing the same drives. And then up here, more and more you can find quad cores machines. Those are pretty easy to come by to get a quick 16 cores. You can, and the prices are going down. I know a lot of people go, oh, this is crazy, Rob. I can't afford to do all that. But again, keep in mind, these are for the biggest systems, where you're spending tens of millions of dollars anyway just to buy devices. So you're getting more commodity servers. I could go on the Dell website today and buy a quad core server with this kind of configuration, pretty cheap these days. Probably under $20,000, maybe even $10,000. I don't know. So give it all the firepower it needs, because all these databases, there's all this work going on, and so you need all these CPUs to handle it. And I know we think, oh, well, we got all these threads, and I can do more than the cores I have. Don't get caught in that trap. Try to, and I'll show you. I'm about to go in and look at one of the servers, but there's kind of a matching that you'll try to do with a number of processes, a number of synchronization that's going on, and trying to match that up with the number of cores, rather than pushing the limits there, because your performance and scalability will suffer. Right here, I just show them using Windows Server R2, 2003, and SQL Server 2005. Obviously, we've come out with Windows Server 2008, and we got SQL 2008. So those are new things to look at. But SQL Server 2005, though, is very proven, and obviously I have way more experience with it than 2008 because it just came out. I will tell you, though, we didn't change anything in replication when we upgraded to SQL 2008. So people ask me, is there anything new that's going to help me? And the answer is no. the thing that is new about SQL 2008, we have that other sync technology called sync services, and it is able to take advantage of a new change tracking engine built in SQL Server 2008, which doesn't have to use triggers to take care of things, to keep things in the tables all in sync. So you get more efficiency there. The one thing I will tell you that has nothing to do with replication, but it has everything to do with something going over a network. The SQL Server team worked very closely with the Windows Server team when building their new products, their 2008 products. And the Windows Server 2008 has a whole different networking stack, a new TCP/IP stack. And it's amazingly fast and efficient. It's like a total rewrite. It's dramatically different. Well, the SQL Server team, instead of just being a product over here and saying, yeah, we'll run on top of you, they instead decided to work together with the engineers so that the SQL Server 2008 really took advantage and was tuned and integrated to work with Windows Server 2008. The result, I saw some new performance benchmarks. It was a replication, and it was two servers, and they were just going to keep two servers in sync, and one was in California and one was in New York. And it was a bunch of data, and the typical, just a one-way sync just to get data from one side of the United States to the other was, I think it took 220 minutes or something like that, just massive amounts of data. With the new combination of the two new database and new Windows Server with the networking stack, it went to about 2.5 minutes. No changes in replication, no tuning, no nothing that a person had to do. Just the fact that you were on this new platform and got to take advantage of this new networking made all the difference. So little anecdotal evidence there, but that's really good stuff. Now, I talked about having the notion of a separate distributor. So this won't make a lot of sense to people who haven't used replication before. But when you go through these wizards, there's this notion of a publisher. It's publishing the data. There's a distributor. There's there's a whole lot of things that sound like it's a newspaper or a magazine. There's articles, which are the tables and things like that. So the distributor, most people when they do the wizard, the distributor is automatically created on the same box as the publisher. But you have the option of having it on a separate box. And if you can do that, if you have the extra hardware, then you should, because you're going to get more scalability. If you can have a distributor and a publisher connected by gigabit Ethernet, or I know some people even have the new 10 gigabit Ethernet, that it's fast enough connection, then you can scale out your system even further and have more concurrent users at the same time. The distributor will take off all the load off the main publisher. And also, there's other things I haven't talked about yet, like this thing called a snapshot share, your database snapshots, which are kind of what the database looks like the first time a device or a server has to download it. Getting that off the SQL Server, off the primary SQL Server to lighten the load. So those are all things you can do, and that's just kind of an example. But you don't need near the hardware. You can probably just do an 8 gig machine and just a quad core, and you're fine. So let's see here. Let's do a demo. Demos are what it's all about. So I'm going to push the magic button, and my computer's asleep, but not for long. I can feel it waking up. All right, here we go. So I've got 4 VPCs, 4 servers running on my box here. I've created a private network. I've got an Active Directory. I've got the primary publisher. I've got the republisher. And I've got IIS on here. And then, of course, I have the device that's going to replicate. So lots going on here, a lot of moving parts. But I want to accurately show you that this is real and it's not just text on a screen. I want to show you, seeing is believing, right? So let's start off with the publisher. I just want to go through a few things about the publisher. In this case here, I have an example database, Contoso Bottling. Wow, what a surprise, Contoso. It could have been in VentureWorks for all we know. We don't have a lot of imagination there. So real simple database for, tables with customers like Fabricam. Wow. Anyway, distribution centers. In this case, I have 2, one in Seattle and one in Redmond. I have something called order state, which is basically real simplified. And a lot of this database is kind of just a simplified version from the mobile line of business accelerator. So right now, I've just simplified it. You've either placed an order or you've delivered it. I've cut out the things in the middle. So I'm a bottling company. I'm selling products, drinks. So here's all the imaginative drinks I have here, all these flavors. I've got routes, and the routes belong to the city. And so you can see that these are different neighborhoods or cities in and around the greater Seattle area, and they're aligned with one of either the Redmond or the Seattle distribution center. So that's how we tie it in, because we need to have that to break it apart. And then, of course, we have orders that will be placed. And so I think I've already got the orders table open. And so the order is, belongs to a particular customer ID, which we know belongs to a given route. It also belongs to a given distribution center. And then there's the order state. It's either placed or it's delivered. And then order details, just, slightly more. And you can see here I'm using GUIDs instead of identity columns. And the product ID matches, one of the flavors of the drinks and the quantity. So anyway, now, one of the things I'm doing here, when I first made this database, it wasn't so easy to find things that belong to other things. You always want to give your database all the help it can get. So what I'm really saying is denormalize your database. You might build this super normalized third normal form database, and you probably feel really proud of it. But it's not going to buy you anything when you need to start breaking it out and republishing. And I'll get to the reason is these filters that we have. Let's look at the properties. So I've published this database, and this first screen here just kind of is a generic general screen. The subscription expiration I want to talk about just slightly here. By default, it's set to subscriptions expiring in 14 days. Now what that means is we have some system tables that are hidden that need to be unhidden and be on their own spindles that are keeping track of all that data that's changed since the last time you synchronized. And the more people you have syncing, and the longer this time is, like 14 days, the more data are in these tables. There's a table called Gen History that's showing the start and finish, and then there's MS Merge Contents, which actually has all the data. There's a Tombstone table that shows all the deletes and things like that. A lot of work happens there. You think all the work's just happening on your database that you're publishing, and you'll be really surprised to find out that actually all the work's happening in these system tables. And they will bring your system to its knees. So you need to think about how you can help yourself and help SQL Server. So one way you can do it is, well, for starters, you saw when I started out here, never ever have this highlighted where subscriptions never expire. It means SQL Server is going to manage all this growing data forever. That'll kill you. So up here, take this subscription time and make it as low as possible. So what that means, as I said, it's gathering data about you. So if I log in and I synchronize, and then right now this 14 days, if I don't synchronize again for 2 weeks, maybe I went on vacation and I come back on the let's say I come back on the 16th day. SQL Server will say, your subscription's expired, and I cleaned out all the data that I was carrying around for you, and so you're going to have to reinitialize your subscription. So what that means is you're going to have to pull down the whole database again, which is fine. So I would say, though, in your enterprise, make that number as low as possible. If your people are synchronizing every day as part of their job, why don't you lower it down to something that maybe allows for a weekend or even allows for a 3-day weekend and keeps it from expiring. So maybe try 3 or 4 days. Every enterprise is different in the way you do your business. But keeping that low and keeping those system tables on other spindles is going to help you a lot, because it means less data is being tracked for any given user. So it's very important. Articles, this is basically all the tables I just showed you. And see, this is real simple. There's a wizard. I've already done the wizard, so I'm just showing you a property deal that shows you what I've done. And so it basically just shows I've checked the tables that I want to make available to, and then you can expand that, and it shows all the columns. Now in this case, I have all the columns available, but you could choose to pick and choose the ones you may not want all the columns to go out, and that reduces the amount of data, which is great. You've also got, on each table, you've got properties for these articles. Now the really quick thing, notice this checkbox here says highlight table is download only. For all your lookup tables, your reference tables where the clients aren't changing them, try to mark all those as download only. That means your client, people are doing less work because we're not tracking changes there. So everybody's doing less work. So for every lookup table, and you can see in this case, except for orders and order details, which are your transactional tables where things are changing, Everything else is marked as download only. We also have article properties. For every given article, I don't have to go too deep on this. A lot of these settings you should just leave alone. But down here, we have things like for identity columns, this publisher range size. Now in this case, I've got identity columns on these download only tables, and so it's not as big a deal. And then for the transactional tables, I'm using GUID, so I don't care there. But basically what it's showing you is kind of what I said. It's got this 10,000, is the range, and the subscriber range, each subscriber gets 1,000 each. So that's what it's pushing down for each one of those. That's going to matter in republishing because then you're going to have a smaller subset for the devices below the republishers. We also have tracking level. By default, the optimized is row level tracking, but you also have the option of doing column level tracking. So unlike other replication synchronization systems out here, SQL Server Merge Replication has built-in conflict negotiation and having a winner, basically. If you have we have a bunch of different rules for different kinds of conflicts. If I make a change to a table row and my friend makes a change to the same table row, SQL Server is going to say, well, I've got a conflict, I need to resolve it. Whose change gets to win? Well, if you switch it to column level tracking, I could make a change to, let's say, the last name column of a row, and my friend could make a change to the first name column of a row, and there would be no conflict. So it's still a no free lunch, double-edged sword, because while it means SQL Server will do less work around the conflicts, it has to track more metadata to manage the ability to do column level tracking. So unless you really need it, I would just leave it alone and keep it set to row level tracking. Also, you have resolvers. Most of the things you can use the default conflict resolver, but you can click here and there's custom resolvers, date time, early wins, late wins. There's all kinds of scenarios to decide which person wins when there's a conflict. And then you can create your own resolvers too. You can write them in managed code, stored procedures to create your own. And I've got customers who do that actually, and you can even debug them and things like that. So a lot of capabilities here. Filter rows. Here's where the fun stuff happens. Filters gives you a lot of power out of the box that you would otherwise, if you were doing some code-based sync or something, you'd have to write code to do this. So I talked about the hostname filter. For a distribution center, when someone replicates with a distribution center, they're going to pass along these filters, they're going to pass along their host name, this value that they're going to pass along as a filter. So I'm going to pass along, in this case, maybe I'm going to pass along Redmond as my distribution center. Well, the net effect of that is a server-side where clause. And so I pass up Redmond in the host name value. It's a dynamic, it could have been anything. And so basically what I said here in this first filter is just give me, filter the distribution center by host name. So if I pass Redmond, then it's going to know what the distribution center ID is. Then the next thing is then you can hang other tables off of that primary filter. Because I don't want to just limit this one table and just give you this one table about Redmond. You just found out the ID. But if I have a primary column like distribution center ID and a foreign key in another table, I can limit what comes from all these other tables to you. So the next one here is customers. And so we have these great UI wizards to help you build join filters where you say, okay, I've got my distribution center is my primary over here on the left, and then customers, the table I want to join to it. And luckily, distribution center is a primary and a foreign key. And so now it's done a join. And so now customer table is going to be only giving you customer information that matches, in this case, the Redmond distribution center. And on and on. Same with orders, and then all the way down to order details. It's the same kind of thing, one after the other. Now, keep in mind, don't go too deep with this. I see people do, another term is, sometimes we give you all the rope you need to hang yourself, and we give you too much functionality. And I see people do that. You can go. I've seen customers just going crazy with rows, with filters. Dozens, hundreds of filters, and going really deep. 10 deep or whatever. There's a cost to that. great functionality. You know, SQL Server replicating at full speed with no filters, and then the more filters you have, you can imagine SQL Server's having to do a little work. I got to do something for you every time you sync to limit that. So you're going to take a performance hit, you know, the more filters you have or the deeper they go. Having filters that are just kind of up at the top level aren't too bad, but once you get down to maybe 5 levels deep and further, then it can really start to slow things down for you. So snapshot. Snapshot's just this culmination of you know, BCP tables. It's what the original database is going to look like. There's a folder, you have a share. If you do a separate distributor, it'll be out with the distributor. If you have it on, if combined, it'll just be on the same box. So that's where that goes. Subscription options here. Again, host name is how we filter. You'll see things here, I'll talk about this just briefly. Pre-compute partitions and optimized synchronization. Without going too deep into what those do, SQL Server can do some extra work to optimize the performance for you of synchronizing. And that's great, but it also has to store more metadata and do some more things for you in order to do that. So again, things that may give you better performance may decrease your scalability. So if you need to have a very, very scalable system, you may choose to have both of these set to false. And rather, the other big thing here is limit concurrent processes. This goes back to the picture where I showed you all the cores on the SQL Server. By default, it says false. It means as many connections can come in as you want. That's bad. What you need to do is you need to set it to true, and then you need to define how many concurrent merge processes happen. Well, in our case, if we have a 16-core machine, why don't we just make it 16 or 15? And you'll just be amazed. A lot of people go, oh, you're limiting it. You're not going to be able to get as much done. Not as many people will be able to sync at the same time. Well, it's counterintuitive. The opposite is actually true. The fewer people I let in, the faster each person gets done, and it turns out I can take care of more people than I ever could before. You will see a false reading sometimes, like when I'm doing a stress test with a bunch of test harness, so it's simulating, you know, let's say 1,000 clients, all syncing at the same time, and I let them all in at the same time. SQL Server, you may look on the box and looking at the CPU and everything, and it looks like it's really low, and you're trying to talk to your boss saying, I need more horsepower for this machine, I need more CPUs, and your boss might say, no, you don't. Look, it's hardly even doing anything. It's a false reading. What really happens is the system is almost paralyzed. There's so many connections, and it's all trying to do so much at one time that nothing happens. And then what magically happens is when you set this to false and then have it match the cores on your machine, utilization goes up and lots of work goes on, and people get in milliseconds, depending on how much data, and they get in and get out, and the next person gets in, and scalability and performance goes way up. So here I've got, in this deal, I've got the order state of placed. So let's move along here. We'll talk about the regional republisher. So this will be the second SQL Server I have on here. Very similar. I kind of talked to you. There's a certain kind of a push type replication subscription that it'll have, and it's always running continuously. So the master SQL Server and the leaf node ones, if you want to call them that, they're syncing all the time instead of on demand. So there's always that connection. And again, the SQL Server down here is passing a value up there. And you can't run the publication wizard against the republisher until you create a subscription, and then you synchronize the subscription and initialize the database, and it pulls down this filtered database. And then once you have that, then you can run the wizard against it and then republish it down. And again, now I mentioned earlier about the identity columns. And let's just go to that. These slides are going to look pretty similar to what you had before. You know, except you probably won't need as big a SQL Server for the republishers because it's working with less data than the global one, and so you can get away with less RAM and fewer CPUs. The same with a separate distributor again. So let's do a demo real quick on that and see what that looks like. So let's look at publisher number 2. And so in this case, you see that I have subscribed. I have a subscription here, I have to look at it from the other machine. Actually, let me go to Publisher 1, and I can look at Publisher 2's subscription properties from here. So right here in this dialog box, it shows the publication databases Contoso bottling, and I've created a subscription called Bottler Pub. Publisher 2 is that, and it's sending Redmond as its host name, and it's a server type subscription. So that's all I'm going to worry about right here, actually. So I pulled that down, and so the realization, instead of seeing lots of customers, now you see only 2 customers in this case. And again, this is a small database simplified just for demonstration purposes, but you could do as big as you want. So in this case, you just see the customers that belong to this distribution center, which in this case is 2 for Redmond, and they're on different routes. And then likewise, the routes will be reduced, and then the orders, you only see I've got 1 order here. So we're getting smaller and smaller data as we go down. Okay, I'm going to talk about some tuning things, and this list could go on forever, actually. And then that's why I have the book. And I've got a new book, and as many tips and tricks as I have in there, I probably have twice as many now for the new one. So there's a lot of stuff you can do. There's a merge agent profile that's a default profile, and it basically shows how much work's going on. It does little round trips and grabbing data changes from the server and applying it down to SQL Compact or applying it to the subscription SQL Server. You can change that profile to have it do more work per round trip, depending on the confidence and how much bandwidth you have. So in between your 2 servers, they may be in the same data center with gigabit Ethernet between them. So you can change the profile to high volume server-to-server profile, and they'll do more work per round trip. They'll grab more rows of data and take it over before they go back and get another one. And in fact, you can do custom profiles. I've been with some customers when you're using SQL Server or even SQL Compact, because now we can do SQL Compact on the desktop. I've got some customers that are doing it over a LAN, over Ethernet, or they're doing it over Wi-Fi. They have great bandwidth. You can create a custom profile based on server-to-server, and you can change the values to do even more work than the server-to-server profile does. And so, as an example of performance, there was one customer I worked with, a big retail outlet, company, department store in the United States, and it was taking him 32 minutes to pull down the data. And through changing things like this and a lot of the other, but this had a big impact, I got it down to under 3 minutes. And a lot of it had to do with how much work it was doing per round trip. It's going to do lots of round trips, and so it's all about bandwidth. Now, on the other side, if you have GPRS and slow bandwidth, you may not want it to be as high. So maybe between that republisher that's talking through IIS to your device, you may want to lower that to make it more reliable. So it's going to send less information over the wire per round trip to have a more likelihood of being successful. If you're over GPRS and I try to force a ton of data through it, that's not going to work out too well. Okay, the second thing is something you may never have heard of before. It's called byte alignment. On Windows Server 2003, on XP and anything older, believe it or not, the partitions, when you create a partition on a drive, it turns out it's not perfectly aligned with the actual disk, the sectors on the disk. And so what that means is 33% of the time, a third of the time, it's having to do 2 reads or 2 writes to get information that percentage of the time when accessing the disk, because it's slightly misaligned. But there's a way to fix that. There's a command line utility you can use in Windows Server called diskpart. And it allows you to specify a 64K byte alignment that perfectly aligns your partition to the drive. And then when you format it with NTFS, instead of the default allocation, you can also set that allocation to 64K as well. And the net result of that is you may find yourself getting up to 20, 25, maybe 30% in performance, overall from your disk I/O. And we're all about disk I/O when it comes to SQL Server. And this applies to people with Exchange Server, email server as well. Use that. Now, today with Windows Server 2008, obviously we recognize this. And so when you do partitions by default on Server 2008, they're byte aligned already automatically. So it's just something you need to know about when you're running Windows Server 2003.
I don't know, has anybody used the performance dashboard? You can download it for SQL Server. It's a really cool tool. It helps you find out. You turn it on and you can do replication, and it'll tell you the indexes that you're missing. So much of the performance of this technology is a lot of just basic DBA database stuff. And it turns out indexes are one of the most crucial things in the whole system. So anyway, performance dashboard is an easy way. It comes back and reports and tells you you're missing all these indexes in these tables, and it even has the code where you can create the indexes for you right there, and then you can rerun it, and you should see a dramatic improvement in performance. In fact, I've even seen scenarios where even if I was able to, let's just say, have a scenario of one user replicating a lot of data, and I'm able to get the data faster than ever before because I've tried everything else in the book, and it's great, but I've noticed that all my CPUs, maybe I have an 8-core, and all CPUs are pegged at 90 or 100%. Well, that's great that one user got everything he needed in time, but there's going to be no scalability. And then I run the performance, the dashboard, and it finds the missing indexes. I place them in there, then I rerun the thing, and all of a sudden the CPU goes way down. And now I'm going to have more scalability for more users. It's a critical thing to do, because if SQL Server is doing, because those filters where it's doing where clauses on the server, if it's doing table scans to find the answer to those where clauses, that's going to slow down your whole system and bring it to its knees. So indexes are critical, just like they're critical with any other database thing. Min and max memory. If you right-click on the properties of your database at the highest level, you can set a min and max memory. Instead of SQL Server just allocating and deallocating memory as needed to do stuff, you can force SQL Server to go to a certain level of memory. So let's say, for instance, I have 32 gig of RAM on my server. I would go in and set the min and max memory to 30 gig of RAM. I'm going to allow 2 gig of RAM for the operating system, but I want SQL Server to take and keep all that RAM all the time, which is going to yield better performance. It's not going to, you won't have the memory fragmentation. You aren't going to be allocating and deallocating, or if you're doing something really difficult and you don't have enough RAM yet, SQL Server is going to work to grab a bunch of memory locations to do it. It's going to have it and keep it. That's going to help you with performance. Defragging indexes or rebuilding indexes on a routine basis. You can do it by hand or with SQL jobs. That's also going to help you in your performance. I already mentioned lookup tables, download only. One other thing I'd mention also is, I remember I talked to you about the snapshot, which is the first thing you get. By default, you saw that 14 days. By default, it's going to create a new snapshot for you every 14 days. You can set the SQL job to have that thing run every night, and it'll create new snapshots every night, so that when you have new users who come onto the system for the first time and they download that snapshot, the data will be fresher. Because keep in mind, even with that, people talk about the painful first time I have to download the whole database. So it's all the data. So I'm not getting any benefit from how Merge Replication does diffs. But it could even be worse. If my snapshot is 10 days old and I pull down the snapshot, I'm not done with the pain yet. I just began. I get the snapshot, and then I've got to catch up with where the database really is today, because it's out of date. So have new snapshots. It doesn't hurt anything in the middle of the night. Have them create new snapshots every night so that it's fresher, so that the data, the diff between what you get as that new snapshot and the reality is smaller. And the same with people who have to reinitialize because their subscription expired. I mentioned keeping your expiration to the lowest possible. Just stick with x64 servers. I think that goes without saying now, or I hope it does, at least with SQL Server. It's just a gimme. There's, the concurrent connections. I mentioned, limiting the connections to the number of cores you have. That's also going to play out down at the IS level, which I haven't gotten to. And then RAID 10, I talked about the spindles, and you saw the pictures up there. So the server agent. This is an ISAPI DLL that runs on IIS. It's kind of your middleware around this. And so there's a wizard that lets you install that in a virtual directory in IIS. Some little tips. The IIS server, I'll show you a UI here, a picture in a second, but it doesn't have to be nearly as beefy, and it doesn't even have to be 64-bit, actually, as it turns out, because it doesn't need as much RAM. But typically, use basic authentication. I know you'll see other options, like I can use Windows authentication, whatever, but Kerberos going hopping machines doesn't always work so well. So use basic, rapid, and SSL. That's your best job, at least from the device going through IIS. Again, with I/O, the ISAPI DLL. I know a lot of people go, oh, it's just a database, it's fast, it's in, or not a database, but it's a web server and it's in memory. Well, actually, there's I/O going on. The ISAPI DLL is reading and writing these little in and out files on the hard drive. And it's part of the magic of why merge replication works so much better than any other sync technology when it comes to devices with low memory. We don't try to send a whole big payload of data that a device can't handle because its working set of memory is not big enough. It sends little bit blocks at a time that a device can handle. So it's doing I/O, and whenever there's I/O, then we need to give I/O all the help we can. And so that ISAPI DLL, when you create your virtual directory, have it on a separate drive than the main drive, the C drive, basically. And if you can, do RAID 10 on that, more the better. Anything, when I go help customers, a lot of customers try to build their system. Some are successful, and then sometimes I get a phone call, and they go, come out and help us. We don't have scalability, we don't have performance. And I attack every single tier, because as you can see from my slides, there is something to do at every tier of the system to improve performance all along the way. So, and then you can use load balancers and have multiple IIS boxes. And so typical, let's see here, I've got pictures of it. Here's what you typically need to do. Really low end, just use a 1U server that's a dual core is fine. You only need about 2 gig of RAM to run this DLL because it never uses too much memory. I found a memory leak years ago and we fixed it. It used to use a lot more memory. Now the ISAPI DLL it'll sit there hovering around 60 to 70 meg of memory inside a worker process in IIS. So you don't have to have 64-bit or don't have to have a lot of memory on the server to get the job done. The key takeaway there, though, is it's this matching. So if your SQL Server is 16 cores or 8 cores or whatever, and you've got it limited to 8 processes, do the same with the IIS out here. IIS by default is designed, actually here I'll show you. Let me go over the demo. By default, IIS is designed to have the ISAPI DLL spin up 3 thread pools of 20 threads each, so 60 threads. And some people think more threads are better, so let's just turn it up higher. Kind of back to what I was showing by limiting. So if there's a theme to anything I say today, it's less is more. So what you do in IIS is we actually want to throttle it back. We want fewer threads, so let's have the threads match the cores. This is kind of an example of the wizard you use to install that. And you can see the ISAPI DLL, SQL CESA, that's so tiny and I can't change the font on there, but that's the DLL that gets called in the virtual directory. And it comes into memory and creates these thread pools to start doing the work and reconciling changes and talking to SQL Server and talking to your devices. But you have this easy to use wizard here that lets you do that. And then so the big change, or one of them, to attack that most people probably don't think about is there's a registry setting for SQL Compact, and go in here and go to transport, and you will see that these are my settings that I've changed, but by default, you've got, let's get this where you can see, logging level, max pinning requests, and threads per pool. By default, the threads per pool is set to 20. Change it to 2 to match the 2 cores on your machine. Max pinning requests. People say, oh, you won't be able to have as many people come in at the same time if you do this. IIS actually allows lots of people to queue up when waiting in line for a free thread. So by default, it's set to let 500 devices all at the same time queue up, waiting in line on IIS for the next free worker thread to get its job done. That's bad too. Turn it down to 200. Again, less is more. Use more IIS servers, balanced out cores matching what it looks like at the SQL Server level. You'll just be pleasantly surprised that you'll get more work done and faster because it's partly scalability, but also each person that's coming in, you want them to have a great experience. You want that sync to happen as fast as possible. So that's key here. So less is more on IIS, less is more on SQL Server. This isn't necessarily about the technology of syncing, but
many of these things, the server, SQL Server is in your corporate network. It can see Active Directory. Best practices is using Windows authentication all the way through. We allow you to do several different ways to do it. You could do SA and no password and a whole bunch of other worse practices for security, but I prefer that you send your 3 credentials, username, password, and domain, along when you sync. And it goes through, and IIS uses them. IIS looks at AD, and SQL Server uses it as well. And so one of the things you need to do with all those assets being in your corporate network is how do you make them available to the internet? Devices syncing over the internet. So you have to publish them. So you can, in your DMZ, your perimeter network, you've got your front firewall, and then in between your front and back firewall in the DMZ, you may have a reverse proxy like IIS or ISO Server 2006 or another one that reverse proxy. It publishes basically the path to that IIS server, or you may have you'll probably point to a virtual IP for your load balancer. You'll either use network load balancing built into Windows Server, or you might use F5 or some other load balancing product, but you might point to that to get to that ISAPI DLL, and you publish that out with a reverse proxy. So it makes it available to the internet, you'll create a domain name or something, and that's how you make it available. You can also use System Center Mobile Device Manager with its mobile optimized VPN as another way to pass through and get to that DLL. We've always had PPTP and L2TP IPsec built into going, back to ancient Pocket PCs. It's not optimized for mobile like the new stuff is, but if that's what you have to work with, then that's what you work with. So there's that VPN capability. And the last thing, and I'm just going to be the first to tell you, everything I'm telling you and everything that's in the book and a zillion other things I learned from the School of Hard Knocks. I'm no genius when it comes to this stuff. I've made 10,000 horrible mistakes to find all these answers and more. And so, you kind of stumble and you wonder why something's working strangely. This last one's an interesting example. I'll have customers, when they test a really big sync the first time, especially a long-running sync, and they're testing it on the LAN or over Wi-Fi, and it works great, and then they publish it out to the internet, and they notice it stops or it gets killed, or something happens, or they see some weird errors like there's a mismatch in the bytes expected and things like that. Well, it turns out that it has to do with your front firewall usually, or any of them, that incoming TCP sessions coming into the firewall, typically there's a timeout associated with that. And guess what? It may not be high enough to accommodate a long-running synchronization, potentially. When we came out with direct push technology with Exchange Server to push email to your devices, one of the things we told customers you had to do was turn up the timeouts on these incoming connections to 20 minutes or something like that for Exchange. Well, that applies as well with replication if you're replicating lots of data and maybe that initial sync is really long or whatever, any other scenario where you have a long-running sync. So you need to crank up that timeout so that you don't have your connection chopped in half by your, either by your proxy server or by your front firewall. Subscriber is the last tier. SQL Compact, we're now on version 3.5, SP1. Windows Mobile 6 and 6.1 come with 3.1 in ROM. And if you're doing Merge, that's all you need. But 3.5 SP1 is good. You'll take advantage of the bug fixes and some other new features. And it's a more hardened database, so you definitely go for that. Some of the little tips and tricks around there, you'll usually see this example. And this is the great thing. And that's why replication is awesome. It's not a programming exercise. Your developers are already heads down working hard to develop your mobile applications. You don't want them spending the rest of their time writing synchronization code necessarily. Maybe you do, I don't know. But in this case, it's not a programming exercise. As you saw, it's a server config exercise. And so down on the device, there's just a SQL replication object that you set some properties. Basically, the properties are some security credentials, the names of the servers you got to talk to, which I just showed you, and then call the synchronize method. Some extra stuff, though, that you can do that, again, I found out the hard way, is testing for not only the example you often see on MSDN is if the database is not there, do a sync, add a subscription and pull it down. If it is there, then just do a normal sync. And people think it's kind of binary. That's how it works. Well, there's actually some gray area there. If you try to do a sync and it was interrupted, maybe you dropped connectivity or something and it didn't complete, sometimes you will see your database sitting there on the drive, and if you're using the old logic of if it's there, then everything's good, you would be wrong. Because what happens is a shell of a database that's exactly 20K in size will get created, but it's empty and there's nothing in it. And then you'll try to use it and sync with it, and your application will explode. So the next thing you do is when you test nothing there, get it down, something there, test the size and see how big it is. Is it greater than 20K? If it is, then you have a higher level of confidence that you actually have a real database with tables. And you can take that as far as you want, but that's a quick one that you can do to make sure. Testing network connectivity, I talked about this in my session yesterday on the accelerator, especially a long-running sync. Test to see if the networking is available with a state notification broker on your device, or with the desktop. You can reach out. You could do a HTTP GET real quick request to the ISAP EDLL to see if it's there, just so you have confidence that this is actually going to work before you have a person get into some kind of long-running thing. Async versus sync. We have two ways to do sync from the device. We've had the synchronous version for a long time. You just call synchronize and then you wait and it pulls down. But there's also an async version where you can kind of do, how a lot of methods will have a begin and end, where it'll kind of do a background thread for you and you don't realize it. We have that option too. And so you can do that, so that your device can still be responsive during a synchronization, and then it'll do a callback if you want to tell you when the synchronization is done. It actually can give you a lot of functionality. It can give you callbacks telling you percentage of tables that have been updated and things like that. So there's a lot of extra information you can pass back to the user if you want. Error handling, again, preemptive error handling on testing the size, but also there's a lot of just weird things can happen as I'm in connectivity and I'm not. A lot of those will go into some great command line parameters that no one ever thinks to use on the connection string, having to do with timeouts, having to do with, like for instance, there's the great thing about merge replication, unlike other technologies, is as it's sending blocks of data over, there's a potential timeout one where you can set, I think it defaults a minute, where I'm syncing and then I walk out of coverage and I'm not syncing. But if I walk back in within the timeout that I set, it will resume right where it left off and it doesn't have to start over, which is some great stuff. You can also boost the max buffer size. I don't know if I have that on here. There's a buffer size setting, which is memory you can allocate for operations to happen in memory on the database before it gets committed to the drive. And you can boost that, which will help you synchronize with even bigger tables, and also boost the performance of just SQL CE, SQL Compact on the device. And you can do that with your normal connection string, even when your mobile application working with SQL Compact, having, on the device, having at least, I think the default is 640, make that at least 1024, give it at least a meg of RAM, and then more if you have it. And on the desktop, where you have tons of memory, give it 4, give it 8, give it 16. Lots of memory, so more operations can happen, and so you'll notice a performance boost in SQL Server. Tuning here, this is just device only because desktops are in great shape, but you can read that. Give yourself every chance you can to succeed. I know people think that the performance of Merge is all server based, and it mostly is, but part of it is how fast a device can crunch away too. If my device is having, because different commands are being sent to it. And it could be a bunch of inserts. If I have a faster CPU, I'm going to be able to perform those inserts faster into SQL Compact, and the overall sync will be done more quickly. And then, here's the interesting, I know a lot of people are putting databases on SD cards. The flash ROM will obviously be fastest, but the SD cards, thank goodness for the digital camera industry, which is pushing the envelope on trying to make SD cards faster and mini and micro SD cards for taking pictures. Obviously, we can take advantage of that as well. So don't just indiscriminately buy any old kind of SD card. Try to find faster ones. And the new SDHC, I don't know if I said that right, but the new high capacity ones that can do 4 gig and more, I think by default they're designed to have faster throughput, like at least 20 meg per second or something like that. All that plays a role. So I'm going to go to the device, and we're almost at time, and we're going to just pull this whole thing together because you need to see that this actually works, and it's hard enough, to get all these things going and show you even a simple normal synchronization, but I'm going to show you this multi-server republishing synchronization. So I've got my device here, and there's no database on it,
And I just built a simple little client. It really doesn't, there's not a lot to it here. And it's just called a republishing client. And it's just got, I pulled some of the code from the accelerator just a little bit. You can see it's going to use a config file to grab some settings. Remember all this? Remember I told you you only have to set some properties in the replication object. Well, these are the properties here. So it's just the names of the servers and paths to the ISAPI DLL and things like that. So nothing. This is not a big programming exercise. So I'm going to call sync here, and it's going to synchronize. And what we're looking for is, as you can kind of see over there, so the synchronization happened successfully. And I told it just to put it in the root of the device. So that's where I showed you first. And now you'll see that there's actually a database there called Redmond Bottling. And I apologize if these fonts aren't big enough. These are harder to control on here. Actually, let's see if I can, without exaggerating. But anyway, so here now you see I replicated. And you can use the query analyzer. You can obviously build your own code. We have obviously we spend a lot of time showing you how you can do this yourself. But for really quick things and when you're trying to figure stuff out and analyze, you've got this. You can highlight any table, press play, and you can see I downloaded customer ID and its distribution center 2 and its route number 5 and that's the name of the customer, things like that. So the key thing though here is I want to see, I've got all this data here. I believe I got it. And what I wanted to do, I'm really interested in the orders because I'm a delivery driver. So right here on Publisher 2, you can see on this table here, the orders for customer ID number 1, and the order state is 1. In other words, the order's been placed. So let's take a look at orders. And sure enough, it's 1 and 1, like we expect. So now what we want to do is we want to make a change. I've now delivered my package to the customer, and so this is another great thing of the query analyzer. It can save queries, and you can build dynamic queries here as well. So all I'm going to do, this is real simple. For example, I'm just going to update the order state to equal to 2. It means I've delivered the order where customer ID is number 1. So I'm going to make that change, and then I'm going to sync it, and then I'm going to show you how the sync works, and not only changes the value in the SQL Server just above it, like you would expect normally, but then how it also pushes it up higher to the master SQL Server. So let's do that. And so we're good to go there. I'm going to disconnect from SQL Server, go back to my little simple app, republishing client. Probably should have just kept it running. So we'll launch that again. I'm just going to sync. So no rocket science here at all, which is the message. There is no rocket science in replication down at the device. Spend your time building your app. Don't spend your time worrying about all the other stuff. So we synced. So let's go take a look. There's IIS, and then publisher number 2 is the next one in line. So let me refresh this, and then you can see that the order state has changed to 2 at this level. So at my distribution center, yay, isn't that exciting? But this isn't nearly as exciting. I know the bar is really low, isn't it? The cool thing is actually that it works all the way at the global publisher. Will those changes get propagated all the way up the chain, up my hierarchy? And so typically it takes about a minute, 40, 50, 60 seconds in between this continuous connection that it has between publisher 1 and publisher 2, subscriber 2, if you will. So I'll sit here and just keep refreshing this. Oh, and so you can see it's already changed here. So publisher 1 and publisher 2 have now been updated, and so it worked, and yay, maybe not as exciting as the mobile smackdown last hour when we say yay about crazy demos. But for enterprise applications, this is great stuff. This is obviously a simple example, but hopefully you can now see that this is real and get the gist that, yes, there is a way to build a giant infrastructure for the largest customers, and you can do that with confidence. And so with that, I think we are all done here. Let's see here. I'm sure we have a few little extra things here at the end. I know I've only got a few minutes. You'll be able to get these slides. So I just kind of have a logical design picture that shows you all the way from top to bottom. I kind of showed, you've seen the pyramid in your mind here. I use Windows authentication, so
I don't have to do any special security stuff. I create a group. I created for this private network I created on my laptop. I have a sync domain. I have sync group. And inside that sync group, I created sync user and anybody else. And then so that's how I use to control who can sync and who can't. And then also filtering, right, if you want. And then the publisher, you see publisher and distributor here with their articles, which are the tables that you make available all the way down. SQL Server has this reconciler for Compact and SQL Server. And you can see the little in and out files. So those are the text files that are making the magic happen. And then down to the device. So that's your logical view of what we just did. And in the physical view, when you want to do an extreme example, might look something like this. You saw each zoomed in server with all the spindles and everything it needs. So at a higher level here, this is from the pyramids upside down in this case, but you know, the global publisher, and here I showed you how we have database mirroring that we added in SQL 2005, and if you use the remote distributor, you can use mirroring for your not high availability, for your disaster recovery to fail over in case you have a problem here. And then these would be your distribution centers that are subscribers, and then they're republishing up, and then you have your load balancing pools with IIS, and then either ISA or System Center Mobile Device Manager to get through your DMZ, and then out to laptops, devices, either through 3G or Wi-Fi or whatever mechanism. So that's kind of how that would look like for scenarios. If you don't have an extreme scenario, then we can take one of these away and take one of these away. Or actually, you could take all these away and just have this to an IIS and write to a group of devices, if you're just dealing with thousands of devices. So hopefully, the call to action, hopefully the big takeaway is I showed you a buy and configure solution, which oftentimes makes IT managers happy because they're not having to do a lot of extra work. They just want to buy something and configure it and go. And so that's what this is. We do have sync services for ADO.NET, which is the opposite. It's a developer-focused technology, but it adds flexibility, of course, over Merge, in that since it's at the ADO provider level, it can work with other databases. Merge Replication can only work with SQL Server, so it's only a good candidate for your customers who are already using SQL Server. If you have customers running other databases, and you still want Windows Mobile to be a part of it, or SQL Compact running on anything, then definitely go with syncserviceradio.net to make sure that you get that opportunity to use our technology down at the client. And then hopefully you've seen how you can just cascade and build this kind of hierarchy. And in your mind, you can see that by filtering down, I could keep throwing. If I wanted to build a global solution, I could have SQL Server boxes, republishers at a country level or a region level and things like that. And I can keep expanding, and it's a great way to scale out, because that's always the hard thing, is how do I scale out SQL Server? And this is one great way to do it to help you accomplish your goals. And that's all I got. Thanks for listening.